Hello, everyone, and welcome back to Learning with Jelly. Today is day 15 of our 30-day SQL challenge, where we're going to continue on joining data tables in SQL. Keep in mind that the whole purpose of joins is when you have data that exists across multiple tables, and you need to bring those tables together in order to do a complete analysis. In the previous day, we focused on inner joins and left joins and how right joins can be written as left joins. And we focus on joining two tables. Today, we are going to focus on joining three or more tables, as well as describe, not practice, but describe some other joins that you may hear about in your learnings. So let's go ahead and get started. We are going to describe the full outer join, the union all, as well as a self join. And then we are going to hop into actually practicing joining three or more data tables. If you are new to the SQL 30-day challenge, welcome. The whole goal is to work on SQL in order to learn those beginner to intermediate SQL skills to apply to a project, as well as land an entry-level data role. We are pretty much working Sunday through Friday with Saturdays off now for work-life balance and mental health, but preferably consistently throughout these 30 days. You have two QR codes in front of you. The links will be in the description below. One is a topic list that tells you the videos as well as supplemental practice resources. I highly recommend that you find resources in order to practice joining data, as well as our Facebook support group where you can find a study buddy, give feedback, ask questions, and get help. Be sure that when you encounter an error, you try to troubleshoot using Google or looking up other resources. This way that you can learn from your errors. So let's go ahead and get started. So joins is going to be able to combine rows from two or more tables based off of a related column because we're using relational databases. And if you are not familiar with relational databases, go back to day one to make sure that that terminology sticks in your head. And there's multiple types of joins. So last time we talked about inner joins and left joins and actually practiced these two. Then we talked about the right join, where the right join syntax is not available in SQLite because all right joins can be written as left joins. You just switch the order of the tables. So please, please, please go back to day 14 to kind of get your foundations of joins, where inner joins return matching records between the two tables. This is one of the more common joins that I do utilize. Left joins return every observation in the left table, whether or not it has a matching record, which is also beneficial when you're trying to figure out what dates don't have data associated with it for like time series analysis. But most importantly, you definitely need to know inner joins. Now, full outer joins, as you can tell by the image, returns everything from the left and the right table. So let's look at an example of this because full outer join syntax is not part of SQLite Studio. That is why we're not going to go into SQLite Studio. You can do a mix of left joins as well as unions to kind of accomplish your full outer joins. Keep in mind, full outer joins are not used a lot because you're returning everything. And a lot of our tables in industry now is a lot of data. So you really need to have a special use case for doing a full outer join because these can take days, if not weeks, to run. So here I have two tables. On the top is table A and on the bottom is table B. Notice that table A has my ID and name, and table B also has an ID and department. Notice that in table B, I have 3 IDs, which would be associated with Joe. So in this case, in my results set, on the right hand side, I see all of the columns. I have 1, 2, 3, 4 columns. Keep in mind it's a full outer join, so you're going to see these duplicate in columns unless you drop one. And I see that I have Joe in this case listed twice because his ID is 3 and he worked in the marketing and HR department. So he's probably part-time in both of these departments. Notice that for John, I don't have an ID 1 in the second table, so these are nulls. So you will see nulls in place when there isn't a match. but this returns everything. And this is ideal for small data sets. Like in this example, I want to figure out employees that are working or sharing their labor across multiple departments. I probably don't have that many employees and I probably don't have that many departments. So this could be a good use case. However, to do this on regular data like customers and things of that or insurance claims, it might take forever to run. So make sure you have a use case for this. So the union all. So union all combines two queries results into one result set. So both of the queries must have the same columns. So you need two select statements listing out the same columns. So as you can see here, I have track ID, name as track name from tracks. And in my second select, I have track ID and name as track name. So I am taking the track ID in the name field and they are exactly the same. So this is like when you want to stack rows on top of each other. In order to stack rows on top of each other, you need the same column. So this is if a client is sending you a new data table every quarter, they will send you that same data table that has the same rows spelled the same way every time so that you can stack these tables on top of each other. The columns also need to have the same data type. So if ID is an integer, it needs to be an integer in all the tables to come. And duplicates are not removed. So if there's any duplicate rows, it will stay in this table and maybe that is of interest of you. If you do not want duplicates, you can use the keyword union versus union all. And I'm actually going to hop into SQLite to show you this. We couldn't show full outer joins in a simplistic way. But let's say in this case, and here I have my union all example that you saw, and it is joining tracks or unioning tracks against playlist tracks. So it's going to select all of the tracks from the tracks table, and it's also going to select all of the tracks from the playlist tracks table, only where my playlist ID is equal to 1. So here I have one query, and then after this query, I union all, and I have another complete second query. So these are bringing two queries together. So you can think of this one as having like a little semicolon right there. This will be one query, and this will be the another query. But we take out that semicolon when we use a union all. So in this case, I should get all tracks that came from my tracks table and all tracks that are in that playlist table. So let's see. And when I look at this, I see that I have duplicates because in the tracks table, I also had this track name. In the playlist tracks table, I also had this track name. 2918 only exists in one table. Okay, 109 exists in both, 602, etc. So I can see that I have duplicates here. If I don't want duplicates in this case, I can just do a union. And then now you see that I don't have any duplicates when you scroll down when it comes to track ID. So that is the difference between union all and union. Like I said, one of the use cases is when you're kind of getting in new versions of the same data table and you need to keep appending that onto your database. All right, so let's go back and learn another concept. So self joins. So self joins is going to be utilized when you need to join a table with itself. Now, this is a pretty complex topic in my opinion, but it basically allows you to compare rows within the same table based off of a column. So in this fictional example that I have on the screen, because the order table is not in the Chinook database. There is no table called orders. But in this example, say for instance, I want to compare order one that happened before the next order in the table. So in this case, order two is going to be one day higher or after order one, because I want to look at orders that are placed around the same time from one another. So this is ideal when you have dates, and we're going to talk about dates later, when you can look at pretty much date one of order one and date two of order two, especially if you don't have columns called date one, date two. You can kind of lead into the next day and see what orders were there. So say for instance, I want to compare orders from a certain time frame against orders from another time frame to figure out popular items or what people are ordering. So this whole concept of self joins. Really, if you're interested in self joins, take some time and look at some resources. Okay, so we talked about full outer joins, which that syntax of full outer joins does not exist in SQLite, but in essence, you're pretty much returning everything from both tables. If there is not a match, it is going to fill in a null for those missing columns. And this can take forever. We also learned about union all, where you can stack data that has the same column names on top of each other, and it will consist of duplicates unless you use unions. We talked about self joins, where you can have a table joined against itself. Very great if you want to compare, like I said, dates, and you can see certain patterns of what the purchase order is or what the customer behavior is or how many sales calls you have, and it exists in a single table, and you have to join that table back to itself. Now, for joining three or more tables. So we have two examples that we're going to practice in SQLite. So in the previous day, you joined two tables. Now we're going to join three. So we want to retrieve the album title, the artist name, and the track count for each album within one query. And I put a nice little hint here that you'll need to join three tables. So before I start joining tables, like I've told you time and time again, please look at the entity relationship diagram. So we need album title. So that looks like that could be in the albums table. We need artist name. That looks like it could be in the artist table. And we need track count. That looks like it could be in the tracks table. And when we look here, we can see how we can join things. Artist ID can join to artist ID in albums. And then albums itself can also join to tracks based off of album ID. And we're kind of going to follow that. So let's go ahead and hop into SQLite. And like I said, if you want to practice this on your own, pause. But okay, we need to have album title, artist name, and track. So I'm just going to start in with my select. I know I need album title, so I'm going to go ahead and expand my albums in the columns, and I see that I have title and album. So I'm just going to use an alias for this table, al.title. No, I want to return that. I know I want to return artist name, so let me explain artist name, and I see that is name. I'm going to call it ar.name. And I know I want to return a count of my tracks. So I can do my count function. Okay. And in this case, I want to do this using the tracks. I'm going to call it T track ID. So I want to count up the tracks. So instead of putting a count asterisk, you actually can put the column that you want to count up here. All right, awesome. And so now I have to figure out how to join this. So let's start with albums first, since that's what I listed. So from albums, I can get the artist name. So let me look at albums and artists, and it looks like they both have artist ID in common. So that is what I can join on. So let me do from albums. Okay. And then I'm going to do my inner join syntax, or just join. I'm going to call out the artist table, call that AR. And remember, we need that on clause. So on the common column that they shared. So album has artist ID equal to artist that has artist ID as well. Okay, so that should join those two to actually give me the album title and then the actual name of the artist who wrote the title. Now we could do another inner join for our tracks table because we need to count the number of tracks per album. So now I'm just going to do another interjoin tracks as T. And then now I'm going to do another on thing. So tracks looks like it can be joined by album ID and album ID from the albums table. So I'm going to do albums or AL dot album ID equal to T dot album ID. Okay. And then I want to count the tracks for each album. So I need to do a group by because normally when I have this aggregate function, I want to count by a certain group or else it's just going to turn me a count of all the rows. So I want to actually group by album's title. So I'm going to say title. And then let's just stop right there and see what it gives us. Okay. So I see the album title, I see the name of who did the title, and the number of tracks that is on that album. So this is exactly what I wanted. Feel free to add an order by if you want to order by count ascending or descending or order by alphabetical order of your title. It is all up to you. So I kind of challenge yourself to add another order by clause here. But that is how we get the album title, the artist name, and the track count for every album. Okay, so our second example that I'm going to show is that we need to retrieve a list of playlists with their associated tracks and genre. So I'm just going to look here. I know I'm going to use tracks, and maybe I'm going to use playlist tracks and maybe genres in this case. Okay. So in this case, a list of playlists. So let's say I want the playlist name. Okay. So I am going to look at playlists here. Okay. So I want the actual name of the playlist that looks like that exists in the playlist table. So I'm going to do a select. And I'm going to call this PL. I want to select that name. Let's also select the name of the track was in the track table. So I want to do T.name. And let's also select the name of the genre from the genres table because that's what it wanted us to do. It's the name of the playlist, the name of the track, and the name of the genre. So I'm going to call that G and actually call it name. See how it could get confusing when you don't alias things? So now you have playlist name, track name, G name. They all have similar columns. Okay. So playlist name, that first column comes from playlist. So I'm going to do that. And I'm going to alias it as PL. And I'm going to do my inner join. And I am going to inner join this on actual playlist track so I can get the track ID and then join the track ID onto my tracks table. So sometimes it's a little finagling. So playlist and playlist tracks both have the playlist ID column. So let's go ahead and do that. I'm going to do PL dot playlist ID equal to the playlist, which is going to be playlist tracks. That's what I want. Playlist tracks dot playlist ID. Okay, and what I forgot here is the inner join. So I'm going to put my inner join playlist tracks. And let's go ahead and abbreviate that PT to avoid confusion. And this is my on. Okay, so I'm going to put PT right here. All right, so let's think of this. In order for me to get the track information, I need a track ID. The only way that I can get to my track name is by getting the track ID from the playlist of tracks table. So in this case, I'm joining playlists right here on playlist tracks, playlist ID. So then I can tap into the track ID to then join that against tracks. And once I have tracks, I have the genre ID to then join that with the genres table. So it's a lot going on there. So now let's do another join. So now I'm sitting up here on playlist tracks. This is the table that I'm at. So now I can interjoin playlist tracks on tracks, interjoin tracks, ST. Let's spell enter correctly. And we could do on t.track ID equals to pt.track ID. So it's like a little scavenger hunt. So now since I have tracks, I can now interjoin again to get the genre because genre ID is similar between the genres and tracks table. So interjoin genre on t.genre ID equal to g.genre ID. Okay, so now I should get out the playlist name, the track name, and the genre name by joining. So let's see. No such table playlist. Oh, I forgot to put playlist with an S. So this is how I troubleshoot my errors. Down here it says no such thing as playlists. Awesome. And then it says no thing as playlist tracks. Oh, I put a T, another S. So I put the S in the wrong place here. Join tracks. Alrighty. Genres is genres. So many. All right. So here we go. We have the name, okay, which is our playlist name. We have the track name and we have the genre name. So the name, name one, name two. Awesome. So that was like a little complicated maze, but we got there. Okay, so let's just end up. We learned a lot. Please, please, please go practice your joins, especially join in 3 or more tables. Really go back and kind of think of a question and use that ERD to join 2, 3, or 4 tables together. And please like, comment, and subscribe. I'm going to have the link to the Etsy in the description below, as well as the Buy Me a Coffee link. Thank you so much. Bye bye.